And welcome to your first video lesson from me. Today we're going to learn about naming acids and bases and how to write the formulas for acids and bases. And it's really quite simple. There's just a few rules to follow. The first being that we're always going to look for the AQ symbol. The AQ means that these acids or bases are dissolved in water. And if we have an acid, we're always going to have hydrogen ions dissolved with water. So for example, we have hydrochloric acid and it's in an aqueous solution. We're going to produce hydrogen ions and chlorine ions. Okay? These acids must be dissolved in water to produce hydrogen ions. Acids will always produce hydrogen ions. How to identify if this is an acid? That's simple. It's always going to be hydrogen with a non-metal. So from the right side of your periodic table. A base, on the other hand, is just the opposite. We're now looking for hydroxide ions mixed with a metal. So a metal and a hydroxide ion with the aqueous symbol behind it, that will be your base. So here we have sodium hydroxide, and I have sodium, which is my metal, and I've added it to hydroxide. So naming bases is really quite easy. All we're going to do is name a cation. So here will always be our cation. In this case, it's sodium. And we're going to follow that by the word hydroxide. But we have to make sure that we have this aqueous symbol. So sodium hydroxide. Here I've just made a mistake back there. This bracket should be over here. And I need the aqueous symbol, so I'm sorry about that. But here we have calcium hydroxide. So my calcium, which is my cation, and just adding my hydroxide symbol to it. Now, naming acids, there's three different ways that we're going to name acids. The first way that we're going to talk about is naming an acid with a non-metal. Again, from the right side of your periodic table. So you're going to name this as an acid because we have this AQ. So the first thing you're going to do is write hydro, and then you're going to name that non-metal, but you're going to take the ending off. So this is chlorine. We're going to take the ending off and add an IC. And then we're simply just going to write the word acid. So just like the base where we wrote hydroxide, and we're going to write the word acid here. So here we have hydro, and instead of chlorine, we have chloric and the word acid. So for example, HF, aqueous solution, we know we're talking about an acid. We have hydro, and instead of fluorine, we have fluoric acid. Same with HBr, hydro, instead of bromine, we have bromic acid. And HI, because it's aqueous, I know it's an acid, I have hydroiodic acid instead of iodine. Now, what happens when we name an acid with a polyatomic ion? There's two different endings that we're going to look for. The first one is we're going to add an IC if the anion name ends in ATE. So if I have phosphate, I'm going to make it become phosphate. If I have something that ends in ITE of the polyatomic ion, I'm just going to change the ending to OUS. So if I have nitrite, I'm going to have nitrous. Okay? And then we're just going to add the word acid. We don't need the word hydro here. Because it's a polyatomic ion, we don't use hydro. That's only with nonmetals. So H and O. Well, I know that NO is a polyatomic because they're two large letters together. I look on my pink sheet on the upper right-hand corner to find out what NO is, and I know that it is a nitrate ion. So I'm just going to change the ATE ending to IC and add the word acid. So I have nitric acid. Now HNO2, this is nitrite ion because I'm ending In an ITE, I'm going to change the ending to OUS. So I have nitrous acid. So H2CO3, this is going to be carbonic acid, okay, because this was carbonate. H2SO4 was sulfate, so it's going to be sulfuric acid. SO3 was sulfite, so it's going to become sulfurous acid. Now, how to name a formula. So you need to determine if the anion is present from the name. So hydro means in the name, plus that we have a hydrogen ion plus a nonmetal. IS or OUS means simply that we have a hydrogen plus a polyatomic ion. The cation is always hydrogen, always. That's the rule. So we're going to write down the formulas for the next two ions. So if I have sulfuric, I'm going to change that to sulfate. And to get the word acid, I'm going to add my hydrogen to the front because remember, this is my cation and this is my polyatomic anion. So I'm just going to crisscross and drop and come up with H2SO4 because this 2 crisscrosses and drops down behind the hydrogen. I have another example that I'll show you. It might make a bit more sense. So if I want to know the formula for phosphoric acid, my anion is going to be phosphate, ATE, because when I have IC, I need to look for an ATE. So that I know is PO4 with a charge of 3 minus, while my cation is always H1 plus. I'm going to crisscross and drop. So this 3 is going to drop down behind the hydrogen, and this 1 is dropping down behind the 4. But remember, I don't need to put brackets or anything when it's just a 1. So then my phosphoric acid formula is H3PO4, and make sure and put the aqueous symbol down. So you're going to work on this worksheet today that will be handed out to you. The worksheet is on the front side and the back side has the answers, so give them a try.